Hello everybody, welcome back to another edition of the EcoStruxure Machine Expert training. I'm your host, Leandro Mada, and in this video what we're going to do is to talk about the counters that we have in the software. So let's go to the presentation. So as I mentioned before, I'm going to focus in three different languages: ladder, CFC, and structure test. So in the next slide we can see the different visualizations of these counters that we have in the software. So if we change the view and activate the pen, on the Machine Expert what we have are three different counters: counter up, counter down, and a mix of all of them. Okay, so if we are working in ladder, we have on the toolbar these three icons that give us the direct access to the counters, or we can have the toolbox, and then in function blocks we have the access to these two. Okay, just the counter up, counter down. If you need the counter up down, you can add an empty box and then type the CTUD. As you can see over here, we have different inputs and outputs depending on the counter that we have. So the PB, which is the preset value, okay, is the one that we can do for reset the value that we have in the counter up, and this one for load the value. Okay, so if we press the reset in the counter up, it will put the actual counter value in the output to 0. Okay, and when we assign some pulses over here and the counter is up and reach the PB, then the output will be in true. The opposite way would be the counter down. If you use the PB, which would be the preset, okay, and this one will be the load. So when you activate the load, the value PB will be moved to the CB, and this one, every time you make some pulses on the counter down, will be decrease the value of the CB, and when this value reaches the 0, the output Q will be in true. And then you have the combination of all these two in this one. So this is how it works in ladder. The same behavior is in the CFC. Okay, one important thing is that these three functions that we have, function blocks, are inside the library standard. So you can directly type CTU or CTD or CTUD in the function block, but you can also use the name of the library, which is the namespace.ctu. As this one is not mandatory to use it, you can use directly the name that you have. And if you pay attention, above each function block, what we have is these question marks. These question marks indicates that the function block that we're going to use requires an instance. If we move to, for example, ST, so I can show you the right example, I have defined in the local area these three instances. Okay, as you can see, standard CTU, CTD, and CTUD. Okay, so if we want to call and use this function block, what we need to do is to create an instance of that function block and use the name that we want over here in the question marks. Okay, this is how this works. Okay, and then you can use the function block. In a structure test, it's a little bit different. We don't have this visualization of the block, but what we can do is to, instead of using the name CTUD to call all this part, what we need to do is to call the instance, and when we call the instance, we can see all the same parameters, okay, that we have. If you pay attention, for example, this one, CU preset is all over here, and the output is over here. And if you pay attention here, the inputs have a different icon. So for the inputs of the block, we have the 2 points an equal, and this one we have this sign. Okay, this will indicate that it's going to be an input and this one's going to be an output of the block. So if we go in deeper now in each of the block, here you can have a description of all the different behaviors, okay, of the inputs and outputs. But basically it's what I mentioned before. So the PB value, okay, it will be the preset where you are going to start the increment of values of the input. Okay, so you have the input, and in each of these cycles, okay, this one, this one, this one, the counter value will be incremented. Okay, and if we press the reset, the value that we have is going to be in 0 again. So let's go to the next slide so we can see what we can do. So what we're going to do now is to create a POU in our software so we can use this counter. So let's see, ladder. Okay, not this one, no, let's go with the one that we were working with. Training, let's go over here. So I'm going to show you a different function block called blink. So I'm going to add an empty box, blink, instance, blink, going to always true, and this one is gonna be 1 second. This one requires a definition of the time. This variable is time. Okay, so in every 1-2 seconds, let's try to do it faster. It generates a square signal. So seconds, and then here I'm going to use the counter. As you can see, we have in the top part this part, the counters, or we can go into the toolbox, and here in function blocks we have these two. So you can drag and drop it. Then if you don't press anything or press it on the side, it allows you to create the instance name, which is this one over here. So I'm going to put instance CTU, and the type is CTU, which is the function block name, which you can see over there. So I'm going to press OK. If you don't want to directly create that, okay, you can add a box. Oh, not this one. Just click. Done. Click again. Here you can type the name that you want, for example CTD, and then here you cannot press anything. You can go over here. Let's change the view. So for example, instance counter, and it's going to be CTD. So you can name here the instance, and then you just copy this and paste it over here. Okay, that's a different way to do it. So now I'm going to work with this one, the counter up. I'm going to use the output of the instance. So you can use the instance name and then use dot to access to the inputs and outputs. In this case, I'm going to use the output. Here I can press a reset. Okay, reset. I'm going to create this variable, and the PB will be 50. You can use a variable, for example, instead of the constant value. If I'm not wrong, it's W for word, double word is word. So value reset, no, reset value, and the initialization will be 15. And this one will be word, if I'm not wrong, counter I created. So now in order to check this behavior and in the trace, what I'm going to do is to create a trace so we can easily see this, how it works. So in order to create a trace, let's first log into the controller, just to show you. This is how you can access in the simulation, but I'm going to explain that later. I'm going to make a full download. Okay, make this and run. Here you can see that it's counted. So this one is sending pulses and this one is counter. And if I press this one, let's wait to reach the 15. So this one will be true, true. This one, I'm going to reset it. It's going to be in 0 and it's always reset. So it's going to be 0 always. And there we go. Okay, start content. So if we want to trace this is a useful tool, but I'm going to explain you later. Okay, in details how to add it, configuration. Here you can have this fix. For example, this one going to be the pulses. Here add the variable, and I'm going to use the application ladder instance output. Then I'm going to add another diagram just to show you the reset. Here axis fix, just preparing the escalation and everything, so don't worry. It's going to be reset. Here the value, add variable, just defining all the values that I want. Reset, and add another one. And fix -1, 25. Show variable, a new variable over here, and this one will be the counter value. So now if I download this to the controller, I haven't defined a task. Good, so now we are good to go. So here you can see I'm sending the pulses, and this one, the value if I'm not wrong, has already been exceeded. Okay, so if we separate this vertical, we can see this the code. So now I'm going to reset the counter. So it's gonna be everything 0. See, it's going from, I don't remember the value. So if I remove this, start again, it shall start counting based on the pulses that I have. Okay, so this is how it works. The counter, this is counter up, and the counter down is basically the same. You just define the value to start decreasing and so on. Now, the most important thing now is how you can do this on the in the structured test. Probably it's going to be more, if you're not familiar, it's going to be a little bit tricky if you don't know. So let's create a counter. So instance counter, instance CTU. This one is going to be CTU. And if you want, you can use, for example, a standard, the name of the library, so you know where it came from, .cdu. In order to call this library or this instance, the best way to do is right-click, input assistant. Here you can find the CFC. I wanted to show you the application, but okay. If you go to instance call, you can find the instance that you have on the software. So I have inst CTU, which is this one. So if you go instance call this one, okay, you can see all the inputs and outputs. So that will be much easier for us to work. And then you can assign all the variables over there. Okay, simple as that. And it's important that if you need another counter, you need to add another instance and the name must be different. So if we go back to the presentation, we have already made this. I have already sort of explained this part. I haven't explained this part yet, but let's start with the CTUD. So in this case, CTUD counter all. So I'm going to call this counter now input counter all. You can see that you have all the inputs and outputs. That's going to call this function. So if we call this now, you can see I haven't assigned anything at all here, okay, because you have the possibility to use assign the variables over here or go to the instance and see what do we have. So in this case, this value I'm going to set as 15. Okay, and you can see the counter down QD is on because is 0, so it indicates that the value is 0. Okay, but if you reach the maximum value, okay, the PB, it will be on, and you can see over here in the comments of these ones. So if we count up right value, it just go the counter value is 1 and the QD has disappeared. Can I do this same again, counter up, and if I want to count down, you just move the other one. Okay, so this is how it works. As you can see, it's very simple how to do it. To be honest, I barely use them. Okay, I use structure test to make the counter, and I don't use this function block as I use the byte directly, as I'm going to show you now in a few seconds. So if we disconnect from here and if we go here, this is already checked. And the optional is create a counter without using the function blocks. So if you saw the M251, the part of the counters, I already explained this part, and it's very easy. If we go to here, for example, you can assign a new variable, any type. It no needs to be word. For example, real variable counter. You can assign the same variable again, variable counter +1 or the value that you want. So let me just create this variable now. Here declare variable as a real, in this case, variable counter. Okay, then if you want, for example, to be counter up, if you can do this much easier on ladder. If to turn up x up, then oops, we can move this value over here, paste it, let's create this one, go to definition, it's a boolean, and if you, for example, wants to down, just decrease 1, Declare variable. So perfect. So if we connect now, hopefully there is no errors. It's not a valid statement. Equal. There we go. So now if we connect, we should be able to see one is content up and one is content down. So here it will content up in each cycle of the controller. In this case, so here true, you can see it's content up. But instead of this X up, you can use your own condition to count up. The same for here if you want to decrease. And if you want to reset, probably you will need to make another one for reset, but it's the same. So this is another way to do the counter. Okay, so this is it for the different counters and how we can count in the Machine Expert using different function blocks and also using the syntax as I showed you in the last part. So thank you very much for watching this video and I see you on the next one.